Hi guys, it's Miss Griffin. We're taking a look at Unit 4, Skill 3, Basic Operations with Radicals. So your essential question says, what's the process for adding and subtracting radicals? I included all of them, sorry. Adding, subtracting, multiplying, and dividing with radicals. So we're going to hit all 4 of those topics today. So we've got example 1, adding and subtracting. First step says radicals must have the same number underneath. Break down if able. So underneath the radical here I have square root 2. Underneath the radical here I have square root 2. 2 cannot be broken down, and therefore they are the same but cannot be broken down. So my next step says to add or subtract the coefficients. I have a plus sign in the middle, so I'm taking the coefficient, meaning the number on the outside. That's the 5 and the positive 8, and I'm adding or subtracting. In this case, I'm adding. So 13. And then I keep the number under the radical the same, 13 radical 2. Okay, simple as that. However, sometimes you might have to break them down, or sometimes they cannot combine. So in example 2, I have a radical 3 and a radical 5. Those are different, and therefore I cannot combine them. But wait a second, can I break them down first? 3 cannot be broken down, nor can 5. So I keep this, 4 radical 3 minus 2 radical 5. Number 3, square root 12 minus square root 27. They are not the same number, however, they can be broken down into 2 squared and 3. And this is 3 squared and 3. Again, I'm using the prime factorization on my calculator in order to get these numbers. And I take 2 squared under the radical and it just becomes a 2. Radical 3. I carry down my big minus from up above. The squared and the radical cancel on the 3 squared, so I have 3 radical 3. Now I see that the numbers under the radical are the same, so I take my coefficients and I add or subtract them. In this case it says subtraction. 2 minus 3 is negative 1, carry down the radical. Negative 1 square root 3. In number 4, I look to see first if I can break it down before I try combining. So I have 3 square root, because 54 can certainly be broken down. Type it into your calculator for that prime factorization. And you should be getting 3 squared and then 2 times 3. And then the 24 can be broken down into square root. And we find 2 squared and then 2 times 3. So I've got 3 square roots cancel here times 3 square root of 6, a big plus sign from up top, square root and squared cancel, so 2 square root 6. So if I condense again, I have 9 square root 6 plus 2 square root 6. These are the same radicals, and therefore my coefficients out in front can be combined to make 11 square root 6. So again, break down first, combine coefficients on the outside second, and then, this didn't work out, and then carry down your radical. Take a minute to try the practice on your own. You're just going to pause the video and do this practice right here. The answer is right there off to the side, but don't look until you've tried the practice first. Okay, so my answer for the practice is right there if you want to see it worked out, but we're going to move on to multiplying radicals. So when you multiply, you want to multiply first the coefficients, meaning the outsides. So I take this coefficient of 2 and this coefficient of 5, and I multiply them to get 10. And then we have square root, because now we're going to multiply the stuff underneath the radical, the 6x and the 8x, to give us 48. Ooh, I'm still in the highlighter. 48x squared. And then we have to simplify. Simplifying is your last step in this case, whereas it was your first step in the adding and subtracting. So now I have 10 square root of 2 squared, but then there was still an extra 2 because it was 2 to the third. There's a 3, And then my x squared from that 48, x squared, the x squared should be under the first radical because it can be square rooted. So now I have 10 times 2 times x square root of 6. So in other words, 20x square root 6. So multiply outsides, multiply insides, then reduce. In number 2 over here, we have to take this square root 8 and distribute it to the full parentheses. So now I have 1 square root 8, because technically there's a 1 there, times 3 square root 2. So outsides, 1 times 3 gives me 3. Insides, 8 times 2 gives me 16. But then I distribute a second time, and I have a 1 in front of this square root 3, or the root 3, radical 3, however you want to say it. 1 times 1 gives me 1. Square root of 8 times 3 gives me 24. Now we got to break them both down. 3 square root, plus 1 square root, square root. Ooh, wait a second. Square root 16 is just square root of 4 squared. So I don't need that second root. The square root 24, it breaks down into 2 squared and 2 because it was 2 to the third power. And then the 3, of course, on the right-hand side because it had no perfect square power. So we've got 3 times 4, because the root and the square cancel, plus 2 radical 6. So now this is going to be 12 plus 2 radical 6. There is no radical on that 12, and therefore I cannot combine any further. Leave it. The next one, example 3, still multiplying, but this time it says that I have 6 plus radical 3 squared. The whole quantity is squared, meaning it gets multiplied by itself. So you do want to make sure that you expand first and then multiply. So now I'm double distributing. I've got 6 times 6 to give me 36. 6 times radical 3 is 6 radical 3, plus another one of those, plus radical 3 times radical 3. So there's a 1 out here, a 1 out here. 1 times 1 is 1. And then radical 3 times 3 is 9. So I need to see if I can combine. I need to see if I can simplify. I see a 36 by itself. I see a 6 radical 3 and a 6 radical 3. Those are in common. They both have the same number under the radical. So I've got 36 plus 12 radical 3, because there's 12 of them in total. And then plus, well, square root 9 we know is just 3, so 1 times 3 is 3. I can combine further. I was thinking 36 and further. I can combine 36 and 3 further to make 39 and carry down plus 12 radical 3. Go ahead and start number 4, see what you come up with, and then I'll walk through it with you. So pause the video. So I first need to start by distributing. 4 times 4 is 16. 4 times negative radical 3 is minus 4 radical 3. Then 4 times positive radical 3 is plus 4 radical 3. Then I have minus 1 radical 9. Because again, 3 times 3 is 9 underneath the radical. I'm looking, I see negative 4 radical 3 and positive 4 radical 3. That's like negative 4 plus 4 with radicals attached. Those are the same exact radicals, and therefore they cancel. So now I have 16 minus, well, this turns into 3, which just gives me 13. Flip it over and we'll see some more examples of basic operations. Okay, so now we've done multiplying and now we're going to look at dividing. So to divide radicals, it's sort of the same process as multiplying. You look at the coefficients and you divide them. So this 9 divided by 3 obviously makes a 3. Now we probably want to keep our fraction bar for just a minute to make sure that there's nothing else to go on the bottom besides a 1. And then we take whatever's inside the radical and divide those. It's really messy looking, so I'll erase that. But 180 divided by 5 goes inside the radical. So 180 divided by 5 leaves me with 36. if you can, you want to try to simplify. So here we're going to look at the square root of 36. Well, that's actually just a nice number. So we have 3 times 6 because square root 36 is just 6. And it's still all over 1 if you want to keep that. But of course, you know that 3 times 6 is just 18. 18 over 1 is, again, just 18. Okay. We're going to look at example number 3. So we have, again, outside divided by outside. So 8 divided by 2 is 4. And again, I'm going to keep the fraction just in case it doesn't simplify nicely. And I'm realizing right now that there's a slight typo. This should say 40x. Okay, so please change that. Underneath your square root should say 40x. So then when I take the numbers inside the square root, we now have 40 divided by 2, which is 20, and then x divided by x, because again, we're looking at something like this, 40x divided by 2x, if I were to just make one huge giant square root. Okay, so 40 divided by 2 is 20, x divided by x cancels. Then again, we have to simplify, so we have 4 out in front still. 4 over 1 is just 4, I can stop carrying that 1. And then we have square root, because what we're going to do now is type in 20 to be factored. And when we do that on our calculator, we get 2 squared times 5. So remember, we've got that good radical and the bad radical, the good one with anything that has 2, 4, 6, 8 as the power, so as the exponent. So that means 2 squared goes here, and then the bad one is for all the leftovers, because this is just 5 to the first. And we can't take the square root of 5 to the first and end up with a good number. So we have 4 times, and then again canceling square and square root, we get 2. Square root 5 stays. And then 4 times 2 out in front is just 8. Square root 5 to give us our answer. Okay, looking at example number 5 now. So we're just going to stick with the odds here. Example number 5. So there's no numbers out in front to be multiplied or divided, so we're going to kind of ignore that for a second. And then what we know we can do is take the big square root of everything that's inside. So 40 divided by 8 is just 5. X to the 8th divided by x squared. So if you're struggling with this, you can write it out. 1, 2, 3, 4, 5, 6, 7, 8 divided by x squared, so 2 of them. And then 2 of these x's cancel. We're left with x to the 6th up top. And then same idea with the y's. If you'll notice for the x's, it was x to the 8th divided by x squared. Those exponents just get subtracted. So same idea here, y to the 12th, y to the 4th, just subtract those exponents, and we get y to the 8th. But of course we have to try to simplify this. So we're going to have a good radical and a bad radical. And anything that's an even powered exponent can go into the good one, and anything that's an odd powered exponent can go into the bad one. So this is 5 to the first, so that means 5 to the first is going to go into the bad one. X to the 6th, 6 is even, so we can easily take the square root of that. And then y to the 8th, 8 again is even, and so therefore we can easily take the square root. So when we have this, we now know that we just simply take this even exponent and divide it by 2 when we take the square root. So that's going to be x to the 3rd. And then again take this divided by 2, so that's y to the 4th. And then of course square root of 5 stays. Okay, so if you want, you can go over examples 2 and 4 on your own. I'll put the answers up here, but I'm not going to go through them. Okay, so if you want to try examples 2 and 4 just for that extra practice, go ahead. And I'll put the answers up in just a second. All right, so I've got my work shown here, so you can read through that quickly, and then, of course, you can check your answer with mine. This one is a little interesting. I did want to talk about that for just a second, because we do have this odd exponent on y to the 3rd. So once I divided y to the 8th by y to the 5th, I got y to the 3rd. And then that needs to break down, and remember when we break these down, when it's an odd exponent, we take out the highest even number that can go into it. So that's 2, and then this is what's left over. Okay, so remember, when it's odd, you don't just automatically stick the whole thing in the bad radical. You have to take out the highest even exponent and then leave the y to the first left over. And of course that y to the first can just become a y. Okay, so let us know if you have questions. Otherwise, you're moving on to your practice problems next class. And then notice that you might have this going on at the bottom. I'm so sorry. That should be on the next page. Okay, so please don't forget to write your summary. Just two little questions that you might want to think about are your steps for adding and subtracting radicals, and then your steps for multiplying and dividing radicals. So if you want to split your little summary in half and then just list out your steps, or again, of course, your summary is just anything that's important to you to know about this skill. So maybe you need to write something down when you have the square root of something like x to the fifth. Maybe you forgot about that, where it breaks down into the highest even exponent and then the leftover 1. And then, of course, your radical and this cancel to give you x squared. Okay, so whatever is important to you, you need to put in your summary. Okay, then you're moving on to your practice the next class. All right, have a good one, guys.